Hi, my name is Ignaz at Awesome Designer, and welcome to part 5 from Zero to Azure.NET Under the Hood. Okay, let's see what you have learned in the last part. So you have learned about understanding your tool, and your main tool is Visual Studio. In our case, Visual Studio Express. And what you have learned is how to create a new project. What makes up a project, what are the files within a project, and what are they there for, what are they good for, what are references, properties, what is the app.config file, and what are context-driven menus. And you finished your first little project, HelloAzure. Now let's jump over to what you will learn today. Today you will learn about .NET Under the Hood, what is really driving your applications, your assemblies, and all the parts that make up your apps. This is mainly divided into some parts, like the BCL, the base class library, what it is and what it's good for. Then the framework class library. So what's the framework class library? Why is it here, and how can we use it and utilize it for us? Then you will learn about the Common Language Runtime, what the Common Language Runtime is, what the basic execution process is, every app is going through. And last but not least, you will learn about compilers. So how to compile a project using the command line, and to learn about the switches of the compilers and so on. It will be a very extensive chapter, so prepare some notes. Check out your favorite search engine like Bing, for example, or Google, and look for additional content. And don't forget to read the ebook, which is downloadable from my blog. It will explain everything again more in detail. Okay, then let's start. Let's get first an overview of all of these components. And all of these components are described in what is widely known as the .NET architecture. So what you see on this image about the .NET architecture, or in this diagram, it explains it in a very common way. And this is a way that you will find nearly everywhere. You will find it in most of the Microsoft documentations, maybe in other videos as well, and in books. So we have 4 layers in the Microsoft.NET architecture, and the first layer is the Common Language Specification. You can see the Common Language Specification as a common set of rules for now that every .NET language should follow. So those languages, or the most important languages I know about, are C#, F#, and Visual Basic, and then other programming languages follow. The framework class library, it contains all the great libraries belonging to the .NET framework that can be used with your favorite programming languages. It includes network programming libraries, graphics libraries, or libraries to create user interfaces like Windows, for example. And these libraries have been developed by Microsoft. The BCL, or base class library, it contains all the basic namespaces used for basic input-output operations, for example, like writing and reading files, or file manipulation, value types, and the basic reference types. You have learned about value types and reference types before. If you are unsure what it is, please visit my YouTube channel and start watching the series from the start. Then the fourth layer is the CLR, or Common Language Runtime. This is what really drives .NET, or brings it to execution on any computer or device. So it's the basic host for .NET. .NET runs within the CLR, and Without the CLR, you will be unable to execute your C# apps. Yes, this will change in the future. The .NET Framework team is working on something called .NET Native, and it will contain only a very reduced Common Language Runtime. And you can, if you're familiar with C++, it will create, yes, native .exe files that omit some specific .NET details. And the CLR is tightly integrated into Microsoft Windows today. Previous Windows versions like Windows NT, Windows 95 or 98 or XP, which I cannot recommend today anymore. So if you are running XP today, please update to a newer version. The best is to upgrade to Windows 8.1. It will help you also with your development. Those Windows versions or previous Windows versions need to configure .NET separately. It's not included into the OS directly. So now that you have learned about the basic Microsoft.NET architecture, we are going more into the details, and you will learn about every layer of this Microsoft.NET architecture cake. We will start with the base class library. And the base class library is a simple runtime library for modern languages. And it is the standard library for the language C# as well for other languages. And it provides types to represent the built-in data types, simple file access, custom attributes, string manipulation, and more. So you might ask yourself how to use the BCL class library, and here's what I can tell you. You have used the base class library already in our sample, HelloAzure. And what we have done, we have included the system namespace. And the system namespace is one of the biggest namespaces, if not the biggest namespace at all, within .NET. And it offers all the basic types that are defined in the base class library, and it delivers also the basic I/O functions like console.writeLine and the file functionalities, and everything that is defined in the base class library according to the ECMA standard. It's ECMA 335. You will find the documentation or the link to the documentation within the ebook, and there you can read more about this standard. So, what else is to say about the base class library? We will use many of the namespaces contained inside the base class library, and the next thing we need to learn about .NET and the basic .NET architecture in conjunction with the base class library is about namespaces. So this will be next on our list, and as we continue with this part of the course, we will dive deeper and deeper into the base class library. Now, namespaces are here to give your project an overall structure. And this means that namespaces can be used to divide your project into different parts. Like, for example, the classes that you have to manage customers, for example, or classes that you have to paint things on the screen. And you create namespaces, and those namespaces are not only here to give your assemblies a logical structure, but also to avoid naming clashes between classes. Here's a simple example, and there's a class customer, and the class customer is part of the namespace model, and it is the one and only class with exactly the same name that can exist within the namespace model. Whereas another class called customer within the namespace DTO can exist or can coexist with the previous class in the namespace model. So this is because classes are pulled into the scope of your code, made usable within your code or propagated into it by something that is called their fully qualified name. So the fully qualified name is always the namespace plus the class name. So if you come, for example, from a networking administrative background, you will get the idea very fast. If not, a web address like www.windowsazure.com, for example, is a unique name worldwide that leads you to the contents of the Azure website. Or, for example, your physical address. It is composed of a zip or postal code, a street, and the number of a building within that street. So you are an individual class of your own within your namespace, even if you live in a multi-apartment building, okay? So these are the basics about namespaces, and there are many ways to structure namespaces that you will learn throughout this course. So as we evolve and we get to more complicated or more extended kinds of projects, you will see how Visual Studio is helping you to manage your namespaces, how to structure your projects using folders, and more. Okay, before we switch over to the first demo, let's quickly talk about the Framework Class Library, or FCL, which is a superset of the base class library. And when you see the namespaces included, you will just realize very quickly why it is a superset. It contains a huge amount of sub-namespaces that are part of the system namespace, like system.activities, system add-in, system code DOM, and so on. And all these sub-namespaces of the system namespace are here to help us to perform specific tasks within our projects. You can find this list also in the ebook, and I strongly recommend that you start to explore these namespaces after you have watched the video, just to get a feeling for what tasks they can be used. Now that you have seen enough about namespaces and the framework class library, let's actually see how to browse namespaces in Visual Studio, which will be our first demo for this course.
Nice. I assume you have Visual Studio open. And let me show you now how to use the object browser from within Visual Studio. If you take a look at our source that we have written so far, you can see that we have a namespace here, and this namespace is called part 4. And we have one class within our namespace, and this class is called program. So it's the base class for every kind of console project that we can create in Visual Studio. And if you take a look here on the right side, you can see that we can browse our classes that are contained within our project. Now, to browse all the other namespaces, for example, from the reference that we have here, you can simply go to View, and then you can choose Object Browser, or you can press Ctrl+W+J to open it. So if you choose the menu, you will see the object browser. Let me close it again. And if you press Ctrl+W+J, it will open as well. So in general, the object browser is divided into 3 main views. On the left hand side, you can see the components view, and this is where you can see all of your references or the classes that are referenced within your project. This is the standard view, and you can see that the scope that is currently shown within the object browser is my solution. And this is the standard scope that the object browser will show you. So if you want to browse other scopes, for example, like all Windows Phone 8.1 assemblies, for example, or the Windows Phone SDK 8.0 assemblies, you change the scope to this. Or you can simply choose to view all components. Okay, let us now open here on the left-hand side our project. So you can see that we have here the namespace, which is part 4. And if you go to the right-hand side, you can see in the bottom region of the screen, within the object browser, you can see the namespace part 4, and it is member of part 4. Yeah, this is our project. Okay. Now, if you want, for example, to search something using the object browser, like our program.cs file, you simply type program and hit enter. And you will see the object browser is working a bit, and it will find everything that contains the word program in it. So in our case, we can see part4.program. This is our class, and it will show you the whole tree, the whole inheritance tree, and it will show you the class itself. On the right hand side, you can see that our class has only one method, which is the main method that takes a parameter of type string array. Okay, so now if you want to change, for example, your search expression, or you want to delete it, simply click on this button and it will reset to the normal view. Now if you take a close look at the structure here on the left hand side, you will see that all our references are within the object tree, within object browser. This means you can browse any namespace, like for example system.xml and the sub namespaces. This will give you also a very good idea about how the .NET framework is organized, and in particular now you can see the system.xml namespace, and you can see the system configuration namespace, and all contain classes, structures, and more. Now, as soon as you click a class on the left-hand side, let me choose one here, for example, the XML schema class. You can see on the right-hand side this upper area, this here, which is called the members pane. And underneath the members pane, you can see the description pane. So every time you select, for example, a member from within that class, or a method, for example, you can see in the lower window, which is the description pane, you can see the description for the selected member. So this way you can navigate everything and make yourself comfortable with this class or whatever you like to browse. Okay, and after some browsing, you maybe want to return to the previous elements that you have selected. And this can be done here using these two browse buttons. So clicking on the left-hand button will bring you back to the previous selections. And clicking on the right-hand button will bring you forward to the selections that you have done afterwards. So if you want to load a custom component or create a custom component set of a specific assembly package that you have, or for example, to put it together some frameworks, you can do that by clicking this button here. And you can add then this kind of specific components that are available through the .NET framework. Or for example, you can browse for specific DLL or WinND files and add them here. Now you see that the window is empty now. Let's navigate back, and the object browser will show us where we have been previously. You can control the level of details here by using this little cog button. You can choose to view the namespaces or not. You can see that. Or, for example, you can say, I don't want to see the public members, only private members. Okay, in this case, we have only public members. Let's bring them back. And you can choose also to show inherited members, or, for example, extension methods or extension members that we have not talked about until now. So, this is a little bit of an introduction into the object browser. We will do later on much more with the object browser, and you will see that it is a really useful tool. For now, I like to encourage you to test everything within the object browser and to play with it so that you get familiar or comfortable with it.
Okay, now that you have seen how to browse namespaces in Visual Studio, the next point on our list, and this means diving deeper into the guts of .NET, is the Common Language Runtime. So before we do that, and before we jump into the Common Language Runtime, I will explain all these components to you. We need to do an introduction to compilers and what compilers are, how they work, and how we can enhance our development environment to suit our needs by changing some of the basic components that are delivered with Visual Studio.
Okay, let me introduce you now to the overall concept of compilers. So our source code that we have written is not executable in this form as a text file by your PC, tablet or phone. So to be able to execute this code, we need a tool that is able to take this code, this text file, it's basically a text file, and transform it into something that our computer can understand. Something that is an exe file, for example, or a DLL. And in our case, we are using C#. It is the compiler, the CSC compiler. And the compiler will take this code and transform it into something that the computer can understand. In our case, we are using .NET. And what happens is the compiler will create a DLL file or an .exe file. And it will create MSIL, Microsoft Intermediate Language, or it is called now CIL, Common Intermediate Language, from this code. And it will put this code, this MSIL code, into the DLL or the .exe file. Then this DLL or .exe file at the time of execution will be passed to something that is called JIT, the just-in-time compiler. And this tool will convert the MSIL or CIL to native code that our processor, the central processing unit, can understand and execute. This can be a 32-bit process or a 64-bit process, depending on your CPU and depending on your compilation options. So this is basically what happens when you compile your code with CSC.EXE, which is the C# compiler, and it is utilized under the hood by Visual Studio. But we will see in the next demos how we can use CSC.EXE on the command line and how we can manually compile our code. Okay, now it's time to show you a demo of CSC.EXE and how to work with CSC.EXE on the command line. Please understand that I have not included the tutorial on how to install ConEmu. You will find that description within the ebook that can be downloaded from my blog, and you will find the link within the description for this video. So before you continue, please pause the video, download the ebook, check the section on how to install ConEmu, and then please return to the video. Thank you. Okay, nice. So I hope that you have successfully installed ConEmu according to the instructions within the ebook. And now we are ready to go through our first experiences using command line tools and using CSC.EXE to compile our files. So to actually compile program.cs, the file that we have developed so far, we need to change to the current folder where our Visual Studio projects have been saved by Visual Studio. And this is a path within our Documents folder. And to make it simple, we just utilize something that is called environment variables that is used within consoles to save some specific default settings like values and path values. So in Windows, we have an environment variable that is called home path, and we will use a command that is called cd, which is short for change directory, and we will cd into our home path by typing cd %home path %. And now we hit enter. Please take care that you add always a space between the command and the parameter, in this case home path. Now simply hit enter and you will see that our path has changed. So this was our entry path. This is the folder on C, program files, x86, Microsoft Visual Studio 12.0, Common 7, tools. And now we are in C, users, Ilya in this case. Okay? Now, if you type dir, which is directory, you will see that we have all these kinds of different directories and files within our home path folder. So Visual Studio is saving by standard all our projects in a folder within our documents folder. And now we need to change directory to our documents folder, cd documents. And then we can do something to clear our screen, just to have a better overview of what is happening. We type CLS, which stands for clear screen. And then again, dir, and we hit enter. So after every command that you want to be executed, hit enter. And now you can see the Visual Studio 2013 directory. So we don't want to type that because we are developers and we are a bit lazy. So we type cd and then v, and then we hit tab, the tab key, until we reach the right directory. I do it again. cd, v, tab, tab, and we go to the Visual Studio 2013 directory by hitting enter. Now we can do again a dir to show the files and folders there. And you see there's a projects folder right here. And this is the place where Visual Studio is saving our projects by default. You can change that later on if you want. But for now we will use this standard location. Now we clear the screen again. We say cd, type a capital P or small or lower p, it's no problem, and hit tab. And you see it will resolve the directory for us. So cd projects. Now let's type a dir again, and you see now that we have our from 0 to Azure directory. Now let's cd that. Nice. Let's clear the screen and let's do a dir. And you see our solution file here. So we are now in the root directory of the solution. We can still not see our source code file. And this is what Visual Studio does. It creates a solution file within a folder that's standard. And within that folder, it creates a subfolder for each project, which in our case is part 4. Now we do a cd, part 4. Clear the screen and do a directory again. And now you can see the files that we can see in Visual Studio. So we have our app.config that holds our configuration files. We have a bin folder and an object folder. Those folders are not included into the Visual Studio view. And we have the part 4 CS proj file. We have been in a basic kind of way, we have analyzed CS proj files and what the content is and what it does. And we have a properties folder, later more on that. So our target is the program.cs file. And now if we want to do a simple compilation, we simply type CSC and we type program.cs. So after we hit enter, the C# compiler CSC.EXE will work and it will create for us an exe file. So it's working. You see, for C#5, copyright Microsoft Corporation and so on. Let's clear the screen now. Let's see our directory contents, and you can see that we have a program.exe file, which is 4.096 kilobytes large, okay? When we type program.exe, you have seen I have pressed tab 2 times and hit enter. It will execute our application. And I say no. Okay, thank you for using HelloAzure. Press any key to enter program. So this is what we see now. Great. But there's more, there's way more. So the next command I like to show you is del. So del stands for delete, and I want you to be very careful what you are doing with the delete command, not accidentally delete your files. So maybe if you think it's better, you should back up your files before you start using delete. Okay. So this is all nice, but as developers, we don't want our files to be messed up and to have the exe files within our project root. We will simulate what Visual Studio is doing, and we will move our files using different options, our executable file program.exe, using different options into the debug directory or into the release directory, which both directories are usually located within the bin directory that you can see here. And we will create executables that are good for debugging and executables that are good for executing, because they are optimized by the C# compiler. But first, let us delete now program.exe. To do that, we type del and then we type program. And you see, right now you have to be careful because it is showing up program.cs. We don't want to delete that. We hit tab again and it shows program.exe. To be really sure, you can type the name completely, and yeah, this will give you the right amount of security. So del, and let's clear the screen again, hit enter. And let's list the contents of the directory by typing dir, enter, and you can see that program.exe is gone. Okay. Good. So before we can start to compile our debug and release versions, we need to do a little bit of cleanup. So what we will do, we will clean up the bin debug directory and bin release directory. So to do that, we need to utilize the del command again, and we will use something that is called relative path. This means the current folder that we are in is always indicated by a dot. Okay, by a dot. And this is our current folder. If I type dir here, you will see here the dot directory, which is our current directory. The double dot is the next directory, one level up from the current directory. So if I type, for example, cd ... you will see that we move one folder up from part 4 to the folder from 0 to Azure. I go again into our part 4 folder, cd part 4, and type cls to clean the screen. And now, because we have this operator, I call it operator, the dot, we can start to feed our commands with a relative path. And to delete those files in the bin debug folder, we simply type del space and one dot. This is, we start here in the current folder, and then a backslash, and we type bin. So this will tell delete that we want to delete something starting from our root folder and going deeper into the folder hierarchy into the bin folder. But this is not our target, and therefore we add another backslash and we type debug. And after debug, we type another backslash just to indicate that we want to execute our operation within a debug folder. And then we type star.star. Star.star is stands for any kind of file. And the first star indicates the file name. And the dot indicates the file name extension. For example, like exe.dll, .gif, .jpeg. And the second star says we want to delete all kind of files within this directory, independent of the file extension. So now we are ready and we press enter. And you see that it will ask us if we want to delete all the files that are contained in the bin debug directory, and we type yes, and all the files are gone now. So now that we have cleaned up the debug directory, we clean up the bin release directory, and we hit enter again, and we say yes. Okay, now when we list the debug directory, let's do that. We use again a relative path in debug. You will see that there are no files except for double dot and dot, which are contained in every folder. Okay? And the same is true and valid for the release directory. You can see nothing in there. Okay, let's clear the screen again. And let's continue by compiling our program.cs file to a debug and a release version. Okay. So to actually do that, we need to utilize something that is called options or parameters for a command line tool. In our case, CSC. And you will see when you go to my blog and download the ebook that CSC.EXE has lots of options. And usually options in a DOS environment, and we are working in a DOS environment because we are under Windows, are indicated by a /. So we need two options to tell CSC, first of all, what kind of executable to create, and to include the debug informations. And the first option is debug. So we type CSC followed by a space, and then we type debug. So this is the first parameter option that the first option that we use. Excuse me, it's an option. And CSC now knows that we like to create a debug version of our program.cs file, which will include some additional informations and will create a PDB file. You will learn more about PDB files later. Those are needed to enable Visual Studio to step through a program, even if there's no source code available. So the next parameter we want to say that the debug version has to be outputted, the exe file, or to be placed into the debug folder. And this option is called out. And because we will add a value for out, we need to add the colon directly behind the option, just to let CSC, just to make it possible for CSC to separate the option from the option value. So this is done by a colon. And because we want to output it to the debug directory and call it program.exe, we type bin debug. And you will see that if you type tab, this time it will not work. It will not expand the directories automatically for you, so we have to do that by hand. And we want the output to be program.exe. And this is our target, so program.cs. This is what we want to compile. And now the command line says, CSC, please create us a debug version of our program.cs file and put the output file, the exe file, to our folder bin debug. Okay, let's hit enter. That's it. And now if we list the content of the debug folder, you will see that we have a program.exe file and we have the PDB file that contains the debug informations. Okay, let's now do the same thing for the release version. And the only thing we need to change from our command line that we have entered before, and because we are devs, we don't want to retype everything all the time, you just hit the arrow up button and you can browse through the last commands that you have executed. Okay? So, what we need to do to create the release version is we need to change the debug option. So we remove that. This tells CSC that we want to create the release version. And we need to change this directory name. It's simply by hitting del. So you can move your cursor back and forth using the arrow keys, left and right, and simply place your cursor where you want to insert the replacement, and we type release here. Okay, now we hit the end key, and the cursor will jump to the end of the command line, and we hit enter again. So that's it. And if we type dir bin release, you will see that there is no PDB file here. Okay? And you can see that the exe file, if you compare the exe file from our debug directory and the exe file from our release directory, that the release file is approximately 500 kilobytes smaller than the debug file. This is because the C# compiler has now omitted all the debug informations. Okay? And optimized the exe for faster execution. So this is basically what happens when the C# compiler, CSC.EXE, is executing the compilation process and omitting the debug information and applying the optimization. So let me show you quickly how to list all the available options, and it nearly works the similar way for any kind of command line tools. So if you type CSC and a / and a question mark, this will instruct CSC to show all available options. And as you can see, we have lots of options here. You can scroll simply with your mouse and you can check out all these options. And like I mentioned before, if you download the ebook, you can see all the available options currently at the time of the recording of this video for CSC.EXE. For C# 5.0, C# 6.0 is on the way. And as the course evolves, we will utilize, of course, all the new C# features. So that's basically it for this demo. And in the next few minutes, I will explain you the CLR process and what the CLR is doing, because now you have a little bit of background, what is happening with the compiler and what a compiler is. Okay. So far, so good. Let's go back now to the Common Language Runtime. You have now all the basics to understand how C# is compiling source code, what you can see here in step 1, using the .NET compiler, in our case CSC.EXE, and it is creating in step 3 an assembly. That can be an exe file or a DLL file, for example. So in the fourth step, the Windows PE portable executable loader checks the exe file for a specific method entry that tells the loader what to do when a .NET.exe assembly was found, double-clicked or started using the console. This method is called core.exe main if we have an exe file, and core DLL main if we have a DLL assembly file. So this method can be found in MS Core EE DLL or in a file called clr.dll. So this depends on the version of .NET. So if you have a version of .NET that is greater 4.0, it will be found in clr.dll, or if you have an .NET version smaller 4.0, it will be found in MS Core EE DLL. So in the next step, this method activates the JIT compiling process utilizing CLR JIT DLL. You can see that in step 7. And what happens there is that our entry method gets compiled, and the MSCL code, the managed code, to native code. And this native code is then executed by our CPU. Okay, let's conclude this part of the course by shortly talking about .NET Assemblies and what they are. So, .NET Assemblies are simply spoken all kinds of targets that result in physical files saved to your hard disk. That, for example, a C# compiler is able to generate an output. So other compilers as the VB.NET compiler can do it as well. And assemblies are extensions for every application you create using .NET. One sample scenario is that you include only the required assemblies for your application to create light versions or free versions of your application. And when the user is buying your application and registers your application using a key, you can download additional assemblies to bring in extended functionalities only available for paying customers. So the process of installing an application using a Windows installer, for example, or simply copying the files to the user's machine using Xcopy, is called deployment. And therefore, assemblies represent a deployment unit. So, but assemblies are not the smallest deployment unit possible. Modules are the smallest deployment unit possible. You can create or link new assemblies containing different modules written in different .NET languages. So you can mix them up together, like C# and VB, for example, as long as those languages follow the CLI, Common Language Infrastructure standards. So assemblies have solved the DLL hell problem and allow a much finer grade deployment than it ever was possible before .NET. So what you can see here in the graphics is the basic rough assembly structure, the assembly manifest that contains the assembly metadata, describes the assembly, then the type data. The type data describes the types, classes, methods, members, namespaces, and so on that the assembly contains. Then here's our old friend, the MSIL code that is executed by the CLR using the entry methods we have talked before about. And we have another part, those are the resources that you can add to any assembly, like, for example, text, images, icons, and so on. Okay, so if you want to learn more about .NET Assemblies and about what we have talked in this part of the course, please download the ebook. And if you like the course, or specifically this part, please like the video and share it. You are free to share it everywhere, or even copy the materials. Okay, thank you very much.